This is a review from the, it's not really a section, it's the Chapter 5, what do you call it? Practice test? Practice test. Alright, let's start with the earliest one first. Let's go number 4. And let's see what that looks like. Okay, it's a graph, so it's f of x equals 1/2 to the x. Alright, this doesn't have to be like perfect. It's kind of like a sketch of a graph. And so what you want to do is you want to think, basically do this XY chart. Basically when you do an exponent graph like this, an exponential graph, just put in -1, 0, and 1. That gives you a basic idea what it's going to look like. Put a 0 in there first. 1/2 to the 0 is 1. Anything to the 0 power is 1. Put a 1 in for x. 1/2 to the first is 1/2. Put a -1 in for this. 1/2 to the negative first means you take the inverse of this, or the reciprocal, which would just be a 2. So if I put a -1 right there, it's taking the reciprocal of 1/2, which would be a 2. So you plot these points, -1, 2, 0, 1, and 1, 1/2. Right? And then your graph looks like this. Something like that. A little squiggly, but you get the idea. That's basically what it looks like. Okay, it goes through 0, 1, 1, 1/2, -1, 2, and it just gets really close to this x-axis, never touches, and this just keeps on going up like this. That's all you do. Alright, that was number 4. Number 5. Actually, write these down so I don't have to go back up top all the time. Did you write those down? So, 4, 5, 7, 9, 18, 19, 20. Okay. Number 5. Okay, 7 over 6 to the x power equals 216 over 343. Now we had a whole section where you had to find the same base. Okay, so we want to take this and kind of turn it into 7 over 6. All right, so these numbers aren't really all that familiar to me, and they're probably not that familiar to you. So I'm going to put some stuff in here. Look, I've got a 7 and I got a 6, don't I? So let's start just taking 7 to a few powers. Okay, so let's take 7 to the third power. Let's see what we get. Look at that, right off the bat. Because I knew 7 squared, right? It's 49, so I didn't have to punch that in. So look, 7 to the third power is 343. So this 343 can be written 7 to the third. All right? Let's try 216. Now this is to the third power, so take a wild guess what this possibly could be without putting it into your calculator. If 343 was 7 to the third, this is probably what? 6 to the third, right? So let's try it. 6 to the third. And sure enough, it's 216. Okay, they didn't just put random numbers in here. They rigged these things so it comes out nice. So 216 is 6 to the third. Well, that's the same thing as 6 over 7 to the third. But are we going to leave it like that? Can we just set these things equal to each other now? Nah, because the bases aren't the same. This is 7 over 6. This is 6 over 7. So what I'm going to do is this. I'm going to take this and make it 7 over 6. Well, how can I do that? How can I just turn a 6/7 into a 7/6 if I do what to this? Right, if I flip this, I change this a negative exponent. So I'll make that to the negative third. Now, the bases are exactly the same, aren't they? So 7/6 to the x equals 7/6 to the negative third. The bases are the same. We just take the exponents, set them equal to each other, so x is -3. All right, it's a little bit of a trick. Okay, it's not no logs or anything like that. All you're doing is trying to take one and make it into the same base as this thing over here. And it's just a little bit of manipulation. Again, you may not be familiar with these numbers, but you know it's going to be rigged, and you know you're going to have a base 7 and a base 6 somewhere because you want them to be the same base. And on the test, it'll be the same thing. The numbers will be different, but it's the same exact situation. All right, what's the next one? 7. Okay. All right, number 7. This is kind of the same thing, the same principle. It's the same principle because we want to get the base to be the same. Now, if you look at this, already has a base of 4. Is there any way that we can take this and write it as a base of 4? Well, I could write this 1 over 4 squared, couldn't I? And that's the same thing, all right? What can I do, though, to get this on top and make it a base of 4, not 1 over something? I could turn this into what? 4 to the negative second. Isn't that the same thing? Absolutely. And so now I can write this 4 to the 7 minus 3x. Look at that. That wasn't that hard at all to get them to be the same base. Since there's the same base, what do we do with the exponents? Set them equal to each other. All right, so I added 3x to both sides, added 2 to both sides, divide by 3, so x is 3. All right, so that's the only thing I had to do. Just change this into this, then it was really simple. That was the main part of that problem right there. I am recording this, so you can go and watch it tonight if I go a little bit fast today. But we have a lot of problems to get through, so I'm just going to kind of skim through them quickly. All right, what was the next one? 9. All right, this is kind of the same thing as we did with number 5. We'll do it quickly. So it's 125 over 8 to the x plus 1 power equals 2 fifths to the x minus 1. All right, again, we're trying to get the bases to be the same. Well, I'm going to take this bigger base and try to make it look like the smaller base. All right, so I want to try to make this thing right here look like 2 fifths. Well, let's do this. Let's break these things down. What do you think? 5 to the third, right? 5 to the third is 125. You can put it in your calculator if you wanted to. Okay, but that's a number you should know. But if you don't, use your calculator. What about 8? Can I write that to a third power, something to the third? Sure, 2 to the third. So that's 2 to the third. Look, I got a 5 and a 2, don't I? This is the same thing as 5 over 2 all to the third power. It's the same exact thing, right? Now remember, all this is taken to the what? X plus 1, isn't it? But what I want to do here, I don't want to multiply my exponents just yet. I still need to get this base to look like this base right here. It's close, but it's an inverse, isn't it? So how do I just flip this? Well, if I flip it, I get 2 over 5. But what's that going to change up here? It's going to change this positive 3 to a negative 3. Right? And I keep this x plus 1 the same. So now that is going to equal this. See this right side? I didn't mess with it at all. So all I did was just drop all that straight down. So what did I do? I took this, I broke it down. You could have probably done this a little more efficiently. I just kind of showed you every little step here. All right, but that's what we did. We said this probably has a base of 5 and a base of 2 because I'm trying to get it to be the same as this over here. And sure enough, 5 cubed, 2 cubed. All right, we write it as one fraction with one exponent. I don't want it 5 over 2. I want it 2 over 5. So I take the inverse of this fraction, which means I have to change the sign of my exponent. So I change the sign of that negative 3. Now I've got the same base. If the bases are the same, what do? Just set the exponents equal to each other. And you can do the rest of this. I'm not going to finish this up. You can do it. It's just distribute the negative 3, solve for x, and you can get that yourself. All right? I did the hard part. All right. What's the next one after number 9? 18. All right. Log 5x equals log 2 plus log of x plus 4. Oops. X plus 4. All right, here we go. I'm looking at this. Where do you even begin? Well, I begin right here. I see 2 logs split up by this plus sign. We had a rule for that, didn't we? You're going to have to review your rules. There's a lot of rules that we learn. You're going to have to be able to look at it and say, oh yeah, that's that rule. Okay, you've got to review those things. Look at your notes, look at the old videos, whatever. So this left side right here, I can't really do anything to that. But this right here, when I have 2 logs and it's split up by this plus sign, I can make it just 1 log. All right, but what happens to these numbers? Okay, they multiply, right? So it's 2 times x plus 4. That's our product rule, okay? And what do you think you're going to do with this? What do you think the next step might be? Probably distribute that through, right? That's probably what I would do. And then, so that would be what? 2x plus 8. All right, now look at this. Remember, we talked about this yesterday? The log of this equals the log of that, so this equals that. So watch, the log of this stuff right here is the same thing as the log of this stuff right here. So what must be true about these two things right here? They got to be the same. All right, if they're equal to each other, which it says they are, these two things must be exactly the same. So basically, the logs just cancel each other out, if you want to look at that. Log of this equals log of that, so this equals that. Nobody likes that? It seems to always work in the past, but I guess you guys don't like that one. That's alright. 5x equals what? 2x plus 8. Subtract 2x, that's 3x, equals 8. 8 divided by 3. How did they write the answer? I don't have the answer sheet in front of me. Okay, yeah, so that's what that is. You can keep it 8/3. I'd be perfectly fine with that. Okay, or you can put it into a calculator, get a decimal. But they actually do tell you to round it, don't they? Yeah, so they told you to round it. So, yeah, you do need to, because this is what? 2 2/3, right? Which is 2 point. And rounded to what? The thousandths, correct? So it's like the 6 keeps repeating forever. But if we take it to the third place, it rounds to 7. So that's how you should write it right there. Because it does say to round it to the third place, the thousandths. All right? Rolling right along. 19. So it's 19 and 20, right? Okay. All right, let's take a look at 19. And it looks like we'll have some time to do some more. Depends on how long these take. It's 4x, and that thing is squared. All right. Wow. Let's see, where would you start? Well, I got a logarithm here, don't I? And I got an exponent right here. What's the rule if we have an exponent? Stick it up front, right? So let's do that first of all. So it's 2 log base 4 of x. To tell you the truth, I'm not exactly 100% sure, but I got an idea. If you're squaring something, you multiply it by itself, don't you? You can't just take the squared. You're thinking put this in front of this? I don't think you can, because it's not just x to a power. And our rule says if we just have this number to a power, but this whole thing is being squared. So, I thought I had an idea. Well, it's not really FOIL because there's no pluses in here. But I don't know. I'm just trying something. Times log base 4 of x. I don't know. You know what I could do here? You got to be careful though. See, is this one where you get 2 answers?
Yes.
Yeah. Because we could do this and get 1 answer. Can we take the square root? No. Because well, I gotta be honest, I'm not really sure what to do here. I know I can get one of the answers that they give you, but the other one, see, because I'm thinking we could divide by log 4 of x, right? Log base 4 of x, and get this. But see, what's going to happen if we divide by this, we're actually getting rid of one of our possible answers for this. So we can get one of the answers. This is really not, I'm sure, the way that we do it. I'll have to look at it a little bit later. If this is on the test, I'll just give you a free pass on this one, okay? But it kind of bothers me because they don't have any examples or even any problems in the book that are like this. So I'll have to do a little research on this one. Think a little bit more, but we're just wasting time on this. So let's say we divided both sides, because it's the same thing, right? You can divide both sides, but we are dividing by a variable, in which you really don't want to do. But we can still do this. Watch. 4. Let's change this to exponential form. Probably be the easiest thing. 4 to the second equals x. So x is 16. Is that one of your answers? That, yeah. And what was the other answer? It was 1. Okay. I'll have to look and figure out why. But honestly, I can't tell you right now. I'll have to do a little research on that one. So, that was a good one to ask. Sorry I couldn't help you out. Right, I said I'd give you a free ride on that one. Alright, so we're doing 20 now. Alright, so this is log base 4 of log base 4 of x, which equals 1. Alright, well let's think of this. You know, what if it was this? What if it was just like log base 4 of x equals 1? How would I set this up? If it was log base 4 of x equals 1, what would I do here? I go what? 4 to the what? First. 4 to the first equals x, correct? So x is 4. But it's not that. It's what? It would be what? 4 to the first equals what? Not just x, but this whole thing. Log base 4 of x. Does that make sense? So I just changed it to exponential form. I went 4 to the first equals this number right here. All right? And now we could do this again. Watch. And you're going to see something here in a second, but I'm just kind of showing you the long way. I just want to show you how this works out. So now let's do that again. Let's change this logarithmic form into exponential form. So what's this going to be? This is going to be 4 to the what? 4th, right? 4 to the 4th equals x. So what's x equal to? Whatever 4 to the 4th is. It's some big number. 256 or something like that? Is that what it is? 256. Is that the answer that I gave you? Okay. There you go. Really, that's the only way. I was thinking something would cancel out, but it doesn't. That's probably the way I would do it right there. So you're changing logarithmic form into exponential form twice. Okay, you're going 4 to the first equals this, right? And then you're going 4 to the 4th equals x. 17. All right, let's take a look at 17. 4 to the x plus 6 equals 9 to the 8x minus 0.71. Remember those early ones where you had to solve for x, but you could get the bases to be the same? Can you get the bases to be the same in this problem? No, there's no way. There's no way you can get the base to be the same, right, on this. Because 2 squared is 4. You can't take 2 to anything to get 9, can you? Or no, a whole number. So you can't get the bases the same. So we learned a little rule just recently, what you can do if you can't get the bases the same. Those early problems, it's a little easier to get the bases the same. But on this problem, what's the only thing we can do? Take the log of both sides, exactly right. Now you could take the natural log or the common log. We decided just to take the common log. I think most people are more comfortable with that. So now that we take the log of this side, that helps us out. It really does. It makes things a lot easier for us. Because now I've got some rules that I can apply with logarithms. I can take this and chuck that out front, right? We did that earlier today. And I can also take this right here, and I can take that and chuck that out in front. So let's see what we get. So I've got x plus 6. Since it's a sum, I'm going to put it in parentheses. And then it's going to be log 4 equals, let's take this. This is also a sum, so I'm going to put it out in front in parentheses. And then I'm going to go log 9. Now remember, log 4, it's log base 10 of 4. It's a common log. That's just a number you can put in your calculator. Same thing with this log 9, isn't it? So if this is just a regular old number, I got x's on both sides, so what am I going to have to do? I'm going to distribute, right, because I want to eventually isolate the x. So I'm going to distribute. So look what I get. I get x log of 4. This takes several steps, but they're not real difficult steps. They're real basic Algebra 1 steps. Okay, but they look a little weirder because you got that logarithm stuff. So we're going to go 8x log 9 minus 0.71 log 9. Okay? Now we still have x's on different sides, don't we? But now we've separated everything, so what are we going to do? And really, it's not as hard as it looks because we don't really have to do any arithmetic until the very end when we stick everything into a calculator. I get an x here and an x here. So I want the x's on the same side. So that means I'm going to have to move this whole thing right here to the left side. How do I do that? subtract it. That's right. So I've already got this over here, this x log 4. I'm going to keep that right there. Now, how did I move this over? I subtracted. So I go minus 8x log 9. So that goes away. You with me on that? That was easy. Didn't have to do any arithmetic at all. All we had to do was just move it over, put a minus sign right there. Now I got the x's on the left side. Now we're going to have to take this and move this over. There's a plus in front of it, so how do we get rid of it? We subtract it. So what's already over here? Negative 0.71 log 9. Again, it looks weird, but you haven't really done any real math yet, have you? You haven't done any arithmetic at all. All you've done is move stuff over. That's basically all you've done. So I have to move this 6 log 4 over here, and I do that by subtracting. So it's minus 6 log 4. So that goes away. Now I got x on the left side. So that's nice. That's what I always want, right? Have the x's on the same side. But I got two x's here. No, I've got one here and one here. So what was the rule to get just one x? Give me one math word. Factor. Right. Factor an x. Greatest common factor, you could have said that, or just factor. Factor out an x. So what's left over if I factor out an x? Log 4 minus what? 8 log 9. Right. Don't forget that 8. And that equals all this stuff. And I'll just rewrite it. Minus 6 log 4. And we're almost done. Okay. Again, we really haven't done any arithmetic yet. We're going to wait until the very end to put it in the calculator. Now look, all this stuff right here is being multiplied by x. So how do you get rid of something that's being multiplied? You divide. Now I'm not going to show it over here. It's just too much writing. So what I am going to do, though, is put it over here. So you know it's going to cancel, and so I divide both sides by the log of 4. Now it's a few steps. I could see already a few of you got a little frustrated because you got to do more than 2 steps. Okay, and you've got to get beyond that. All right, you've got to understand that sometimes it takes 4 or 5 steps. But if you take a look at each of the steps that we did, it's a basic. It basically came down to something like this. Watch. You've learned how to do stuff like that. This basically was something like this. Of course, it's a little more complicated because you did have to factor out an x and all that kind of stuff. But it's stuff that we have done earlier in the year with regular numbers, and we're just doing it again with logarithms. So now it's just a matter of putting this into your calculator. All right, so that's sometimes not the easiest thing in the world to do. Let me give you a huge hint. The huge hint is using parentheses in your calculator, right? You don't necessarily have to put the first thing in parentheses, but I like to. All right, I would just to group things together. I'd put everything on the top in parentheses, and I'd also put everything on the bottom in parentheses. All right, the bottom one's the important one that you put in parentheses. The top really doesn't make any difference, but I'm going to do it anyway just because I just want to get used to using that parentheses. All right, so watch. In yellow, put a left parentheses, and I put this stuff. Negative 0.71. Oh, goodness, let's try this again. Let's just clear it. Why do I always hit that? Let's see, negative, right? Point, there we go, 71 log of 9, then minus 6 log of 4. So 6 log of 4. All right? And now, that yellow parentheses, I'm going to close it. You don't really need to, but I do. All right? So divided by, and then I put another parentheses. I take the bottom and I group that in a set of parentheses. And I just put it in just like this. Log of 4. I like to close that one. And then minus 8 log 9. 8 log 9. Close that one. And then, see that yellow one right there? That last one? Put one more parentheses, hit equals, and I should get the answer. Is that what I gave you? All right. You got to practice it, okay? You have to practice it. Now, I just use this calculator because I don't have that TI-30XA, which some of you have. You pretty much do it the same way, except you don't hit log first, then 9. You hit 9, then log. And you have to put a times in between, okay? So on this one right here, if I was going to put that in my TI-30XA, is that what it's called? I would do this first. I would hit 9 log. Then I would hit times 0.71, and then I would hit the plus minus button. That makes it negative. Okay? And then I put minus, and then I would go 4 log times 6. Okay? Actually, I probably would have put a parentheses here first, and then I'd close my parentheses. Hit divide, and then go another parentheses, go 4 log minus, and then 9 log times 8, close the parentheses, hit equals, and you got your answer. It's a lot of steps, but you got to practice it. Okay, you have to practice until you get that correct answer. And so what was that answer? It was 0.6100. Yeah, 0.610. 0.610. 3. Is this the one where it says 3? Yeah, to the thousandths. And that's how you would write your answer right there. Practice it, okay? I can't do that anymore. Let's do another one. We got some time. Let's you could do either early one, a later one. 16. I guess we're doing that whole section, aren't we? That's all right. Because those are probably the toughest ones out of all of them. Make sure you don't forget to do those early ones, or learn how to do those early ones. 1.84. This is x over 3 equals 350. We did one like this either yesterday, day before, forget. First thing we're going to do, we're not even going to worry about this x right now. What's the first thing that we want to get rid of here? What's that? 175, right, the 175. And again, they rigged this for you, didn't they? They rigged this real nice. How do I get rid of the 175? Divide by 175. And put that in your calculator, and you'll be pleasantly pleased. You'll be pleased. Pleasantly pleased. 350 divided by 175. And that gives you 2. It's perfect. Okay? That's why I said you'd like that one. Okay, so that equals 2. So what do I have? I got 1.84 to this power, to the x over 3 power, equals 2. You could do this a couple ways. You could do the log of both sides. Alright? Or you could just change this to logarithmic form. Right? Log base 1.84 of 2 equals x over 3. You could do it that way. You're going to find out either way you do it, you're going to end up with the same exact thing. What would you rather do? Would you rather take the log of both sides or just change this into logarithmic form? Log of both sides? Okay, let's do that then. Alright, so I'm going to take the log of this side and the log of this side. And now we have some rules though, don't we? If I take the log of both sides. Now we have a rule. Since I have a logarithm here, I can take this exponent and chuck it out front. So let's do that. So x over 3 log of 1.84, and that equals just the log 2. Now remember, this log of 1.84 is just a regular number, right? We can deal with it just like we deal with anything else. So how could I get rid of this thing right here? It's being multiplied by x over 3, isn't it? So how do I get rid of something that's being multiplied? Divide it. That's right. So what am I going to be left with? X over 3 equals log 2 over log of 1.84. One more step and you're done. I got to get x by itself. How do I get x by itself? It's being divided. So what's the opposite of division? Multiplication. So we just multiply both sides by 3. So multiply this by 3, multiply this by 3. I believe we did one just like this yesterday. I think it was yesterday. The day before, one or the other. And then you stick that in your calculator. And I'll let you do that in the calculator. That's not that complicated to put it in your calculator. Alright, let's do another one. We've got a few minutes. Come on, let me know. Which one? Number 1? Okay. Number 1 is just plugging and chugging. So it says f of 6. Well, they give you a function. They give you an f function and they give you a g function, correct? So they tell you the f function is equal to 2. No, that's not 2x. It's 2 what? To the x, right. It'll look a little better on the test, okay? Right there, it doesn't look that great like an exponent, but it's 2 to the x. So number 1 says find f of 6. So what do? We just take 6 and put it where? In for the x. So it's just 2 to the 6. And that's what, 64? That's it. 2 is the same thing. Except you're putting into the g function, right? So you look at the g function. The g function says 1/3 to the x. And number 2 says find g of 5.5. The step is the same. It's figuring out what your answer. You might not be able to do that in your head like I did this one in my head. I mean, you would have done this in your calculator anyway, wouldn't you? 2 to the 6, most of you? Yeah. But on this one, what is it? It's 1/3. Where am I putting that 5.5 in for the x? So it's 1/3 to the what? 5.5 power. So it's just a matter of putting this into a calculator. And you should know how to put an exponent in there, right? So let's go 1/3. 1 divided by 3. I'll just put equals. And we'll take that to the what power? 5.5 power. And there it is. What's that? No. Huh. I mean, would you be able to get that without a calculator? 0.00237? Nah. So I would put that into a calculator. Because it says take it 3 decimal places, right? If it's an irrational number, or if it doesn't come out even. Like on that other one, we could have just said 64. We didn't have to have decimal places because it came out even. This one does not come out even. So 3 places would be just stop at 2, right? 0.002. Is that the answer they gave? Okay. So that's how I would write the answer right there. Don't leave it like this because it specifically says if it's an irrational number, which this is, take it 3 decimal places. So you must take it to 3 decimal places. Good time for one more if you want. We've done quite a few of these, almost all of them. Number 8. Okay, let's do number 8. A to the 3/4. Now this method, this technique is a little different than what we've been doing lately. There's no logarithms or anything like this. Watch. I want to get rid of this 3/4 because I want to solve for a. So what I'm going to do is I'm going to take it to the 4/3 power. So I'm going to take this to the 4/3 power. Why did I take it to the 4/3? Because when I multiply these together, it becomes a 1. So that just becomes a to the 1st. Now how do I take 27 to the 4/3? We've talked about this on several occasions. 27 to the 1/3 and take that whole thing to the 4th. 27 to the 1/3 is the cube root of 27, which is just 3. And so it's 3 to the 4th. You should be able to do that in your head. Because 3 squared is 9, right? And another 3 squared is 9. 9 times 9 is 81. There you go. As quick as that. So if you learn the methods, it won't take you that long really to do this test. I mean, there's a few, right? We did that one problem. It took like 4 or 5 steps. Okay, so there's a couple that are going to take a long time. Some of them are really, really, really quick to do. Like number 11, right? You just punch that in a calculator, 2 seconds, you're done. Number 12, pretty much the same thing. Okay, really quick. 13, the change of base theorem. Do you remember the change of base theorem? You didn't ask about this.
We do log to the 70,
log 70.76 divided by, right, log of 8. Exactly right. Okay? Yep, so if you wanted to figure that out, you write it like this. That's the change of base theorem. And then you stick that in a calculator and you got a decimal. Okay? Hang on to both of those worksheets. I'll collect the 5.5b tomorrow. I'm not going to collect... I'll tell you what. I don't usually give extra credit, but I'll give you extra credit. I'll give you like 5 points extra credit. Okay, so I won't count it out of 5. So if you don't turn it in, it won't count against you, the chapter test review. All right, so if you do the chapter test review, and you do it completely, okay, the chapter 5 practice test. Yeah. If you do that, and I did like 3/4 of them already for you, all right? So some of you were writing the stuff down, some were not. But I'll give you 5 points extra credit just as my farewell gift to you, all right? So if you turn both of them in, well, the other one is due. The other one I will count against you if you don't turn it in. But on the practice test, if you turn that in and it's completed, I'll give you 5 points extra credit. How's that sound? All right. Be ready for it. Okay, go over that practice test several times tonight. Because this is, some of you, it's your last shot at getting a good grade. Okay, see you tomorrow.